We are back. Had a great question I noticed in the break. How can you figure out what the neighbors of a hex might be? Right? So let's say you want to do something where if, say, you click on a hex, the adjacent hexes get colorized, in some other way. Or, something. It certainly becomes very important for something like pathfinding. First of all, I will tell you, I do have a full thing to that. If you check my LeftNeighbor 34 project, the Growth Industries, which there's been a couple of videos for on both channels, as well as... I don't know if you go to LeftNeighbor or whatever. If you go, anyway, there's like a billion different links, and I'll try to include it in the link for this video, and they might come up in the chat. But if you download the code to that includes like a full set of ways to figure out what your neighbors are. But generally speaking, what it means is when you click on a hex, the hex needs to know something about itself. So it needs to know, like you've clicked on a hex, and we need to know what its coordinates are. Now, we can sort of extract that from the name because all the hexes are called something, but you could easily imagine a situation where, let's say our hex prefab here has a script on it called, say, hex. Again, you want to minimize how many scripts you add to everything, but as long as it doesn't do much, it's not going to be too painful. And this literally doesn't have to do anything at all. It doesn't need any functions, but let's assume it's got a public x, int x, public int y. Okay, so this is its coordinates in the array. This is not world coordinates. This is our coordinates in the map array. It's not. We're not actually building an array, but that's okay. And then let's say when we spawn our hexes right over here, right? We create the hex, we name it, we give it a position and everything like that. Let's also hex got get component hex.x is equal to x and y. So at this point now, name the game object something sensible. Make sure the hex is aware of its place on the map. For a cleaner hierarchy. Close enough. If it's not right, it's close enough. Parent this hex to the map, or child this hex to the map. I don't know. To do. Quill needs to explain different optimization later. Little thing. Anyway. So now the hex knows where it is, which means now we could write some sort of function on here. We could have a public function that returns, say, imagine an array of hexes that is something like GetNeighbors, right? So we could ask a hex, hey, what are your neighbors? And it could return a list of these things. And the way to do this would be, okay, based on where we are, we have a neighbor that's on the same row as us, so on the same Y, but it's just one to the right and one to the left, right? So we could get something like, so if we are at x, y, the neighbor to our left is at x minus 1, y. And we, for now, the only way we have to find these things is to do something like GameObject.find, and we know we're calling them hex underscore plus x minus 1 plus underscore plus y. Right now, with our current implementation, the only way we have to find this object that's one to our left is by finding something with this name, right? So GameObject LeftNeighbor equals this. The tricksy part is that every other row, the X offset changed a little bit, because if you look when we render here, again, I'm not going to go through all the, and I don't know, return some empty array just so that it compiles. I'm not going to finish this code. Reference not set to a... Oh, right. I added this component to my version in game. I didn't actually set it on the prefab. Try it one more time. Okay, there we go. So remember, so I'm going to look at this view over here. So let's grab one of the ones from the middle here. So this one here is 2_0. So the neighbor to our left, or rather, we should have 6 neighbors, right? If we go here especially, we have 6 neighbors. The left and right, easy peasy. The question is, the 2 neighbors above and below us, what x coordinates are they at? Well, this hex here, this is hex 1, 1. And our neighbor over here is 1, 2. So in this case, the neighbor up and to the left is the same x as we are. The x is the same, it's just the y that changes, okay? So up and to the left for this guy is on the same x, and up and to the right is x plus 1. But if we go to this next row and we look again, that's no longer true. Because this guy over here, this is hex 1, 2. Our neighbors to the top, the neighbor to our top left, is actually x equals 0. So whereas here, our neighbor up and to the left had the same x as we did, here, our neighbor to the top, up and to the left is at x minus 1. And it's actually our neighbor up and to the right that's at x, the same x as we are, as opposed to here it's x plus 1. So in here, the left and right is simple. Okay? Right neighbor is also easy to find. You know, it's literally the same thing, but with x plus 1. Oops, x plus 1. These are obviously terrible names that, you know, just for examples. Let's just, here, we'll use right over here. It's fine. The problem is that our neighbors to our upper left and upper right might be at x minus 1 and x, or they might be at x and x plus 1, depending on whether we are on an even or odd row, i.e. if y modulo 2 is 0 or 1. So then you just have to have little cases in there. And again, I'm not going to finish this. You can see a working example of that in my LeftNeighbor submission, which honestly wasn't even put together that well. You guys can figure out a better way to optimize it. But that's how you would find neighbors. Okay, let's try to squeeze in a scooch of movement, just to say. Let's create an empty object here. And inside of that empty object, we're going to go and create a sphere. There we go. A sphere that's going to be moving around. And I'm going to bring it down. I'm going to scale it down to like a third size. And game object, we're going to make sure you're at 0, 0, 0. And the sphere, we're just going to scooch upwards to by like half a unit or something like that. So if we hit play, excellent. We have a pawn over here. We have something here. Presumably this is some sort of unit, right? This is our hey, we're making a Star Wars game. This is our Death Star. Excellent. We have a Death Star. It's tiny, big scale game. Huge. Each one of these hexes is 1 billion kilometers wide. Excellent. All right, so we have a Death Star. Let's give it a we have a hex mat. Let's go ahead and this is going to be a nice red Death Star. I like it. Okay. So let's say we want to move this bad boy. How do we do that? Well, we've got our mouse clicking code, right? So presumably, one of the things we could do is you could do unit selection in the same way we've done it here. Like right now, in our mouse manager, we're clicking on something, but we don't know, like we know we're clicking on something, but what kind of thing is it? We could figure that out. Again, what we could do is on each one of these objects, we could have an on mouse over type of behavior. But again, if let's say you end up with like 10 different types of things that can be clicked on, right? Like, so you have hexes, you have Death Stars, you have, whatever. You have, a variety of different stuff that can be clicked on. Cities, planets, that sort of stuff, okay? But then you decide, oh, you know what? I've got to change how our click code works, because what if I have the menu open? Then I don't want to be clicking things in the background. That would be weird, right? So then you got to go into each one of those little pieces of code and put in some extra little if statement that says, well, if the main menu is open, then skip, yada, yada, yada. The advantage of doing it here is you have one thing that checks to see, hey, is the main menu open? Well, then let's not do this, because UI code doesn't do mouse clicky things like this the same way. In fact, one of the great questions that comes up all the time is, so let's say we've got our game running here, and let's assume we've got a button. Hold on, let me actually do this. Okay, it's gonna be hard to squeeze in the movement, but let's say we do a UI, and let's make a button on our user interface here, and let's make it big. So it's a 200 by 200 button. So we have a big button in the middle of our screen for no good goddamn reason, right? I'm gonna hit play. So now I want to click on this button. I'm gonna click on the button right here. What happened? We still clicked on the tile. Like, the button is responding. There's like a little bit of an animation that happens when you click on the button, okay? So the UI is correctly responding to the button click. But our code right now is still the same thing. Did the mouse go down? Yeah. Okay. Well, we're doing a raycast out of the camera, and the first thing we're gonna hit is this. UI stuff is not something you can raycast hit using the test we're doing. So it's still behaving exactly the way it was before, which may or may not be correct. I mean, some of these things maybe we don't want them to block raycasts. I don't know. But in this case, like, if our mouse is actually over a UI element, we want to bail out of that other mouse code. So you can do that actually very easily. You do using Unity engine.event system. It's if event system dot current dot is pointer over game object. Boom. Is the mouse over a Unity UI element? It is. So let's not do any of our own custom mouse stuff, because that would be weird. Just return. So now, just with this simple little check, and this is one of the things, people Google this thing all the time. Now, I can still toggle things over here, but as soon as I'm over this button, first of all, it stops spamming the log, I can click the button, and you notice the hexes are not being clicked. So, I have to only do this once. I don't have to remember to do this for every single thing in my game that can be clicked on if this is the only thing that handles in-game mouse clicks. But here, we might want to have some sort of logic of, so what kind of object are we over? Well, and then we could do something like if our hit object dot get component hex not equals null, then we are over a hex. So then what we could do is we could take all of our existing code here and move it something like void mouse over hex. We do this. We pass it a game object, boom, our hit object there. And then they say, oh, we're over a hex. So we're going to call this with our hit object and just pass it on. Then we can do another check. What are we over? And we can put it around. So the hex isn't a game object? No, the hex is a game object. It is a game object. It has a component called hex on it, but it's a normal game object. And then, so then we're going to do that behavior there. But then we've got this one central function for handling all mouse clicks that can bail out if we're over a UI element, or if the game is paused, whatever that would be, could also check if game is paused, if main menu is open, etc., etc., etc. And here's the other thing, is this mouse over hex can have special behavior. Do we have a unit selected? Well, then the mouse over on a hex could do something completely different, right? Here, yeah, so we know what we're mousing over. Maybe we want to show a tooltip. Do we have a unit selected? Because that might change what we do on click. Right? You have a unit selected. When you click on a tile, then you might want to move the unit to that tile instead of change its color. Anyway. What do you want to do if you want it to work over text? Well, what you can do is you can actually get from the event system, you can get information. Well, there's two things. One, that function of is pointer over game object. Yeah, I know. Is there? Oh, that's what the question is. Isn't a hex a game object? Yeah, this is only going to return true if you're over a game object that is part of the event system. This is not just any game object. This is only game objects that are part of the event system, which is a very limited subset. And I believe it will only work for things that are currently interactable. I'm not 100% sure. If I go and disable the button, no. But what I could do is put this inside of a canvas group. Oh, right. Create an empty. And it's in here, canvas group. There we go. So I'm going to put the button inside of this empty game object that has something called a canvas group on it. And you can see it's got a thing called blocks raycast. If I go and take that off, and maybe turn off the interactability as well. No, it still returns that. Okay, so we would actually have to do a test. My bad then. I thought there was a simple solution for the text thing. But no, here, if this returns true, note, we might want to ask the system what kind of object we're over. So for things that aren't buttons, we might not actually want to bail out early. Which are all things we can do. Okay, let's try to get the Death Star moving before we end this. I'm going to just go and remove this canvas because it's getting in the way. And what tile is this one? Wait, did I just... What did I break? I broke something. No, nothing is clickable. Did I screw up here? With the call? Oh, yes. This isn't working. Hold on. Maybe I was doing it right for something else. Yeah. I'm confused, though. It's got a hex component. If hex component is not equal to null, I don't know. Anyway, I'm doing this wrong. Which probably means if I were to turn off, if I were to put back that canvas, there we go. Let me try this again here. Clickable. Clickable. There you go. So now you can click through a button. And the reason is that it doesn't block raycast. I don't think the interactability is the thing. I think it's the block raycasts. Yeah. See, now the button works, and the hex isn't toggling. And if I remove this, the button doesn't work, and the button can be the hex can be toggled. So for text, you would just make sure that your text objects don't block raycasts, which I think by default might actually be true. If I just take some text over here, blah, 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 and make it bigger font maybe, and you can be, I don't know, like full size. And let me take you and move you down, 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 down. I think by default we can click through text. No, I am wrong. So we'd have to put it in a canvas group that does not block interaction. But that would be the way to do it. Anyway, let's move this thing. Go away. Go away. All right. So why isn't this working? Debug.log clicked on, well, not clicked on, but mousing over. It's this. The hex, I did put in the component, right? Hex has got a hex script. Oh no, it's saying clicked on hexagon. What? Oh, I got rid of the parent. God damn, where did that go away? There we go. Excellent, okay. So now we're properly catching that it's a hex. But what if we also want to be able to detect the Death Stars? So let's put the Death Star First of all, let me just move the camera back down so that we can see the Death Star when we start the program. There we go. So now if I click here, I am mousing over the Death Star now. It realizes that. But we don't have any behavior for mousing over the Death Star. So let's give the Death Star some sort of script. All right. So let's call this unit. Thank you very much to all the December supporters over at patreon.com/Quill18creates. And these mic check supporters, we've got Alexander Gutler, we've got Marius Feldvold again, Disco Geek, Ole Peter Talgo, Julian Auger Lafone, Steven Stagger, Michael McClintock, we've got Kale the Quick, Drazion, Wes Oldenboiving, Craig Mortel, Nail Vikstrom, Philip Nichols, Andre Odendahl, Neil Blakely Milner, Speedy Savant, Valiant Cake Fiend, Aaron Toivson, Radel Del Peso, Bunny, Hyper Dingo, and Andrew Henninger. And thank you everyone who watched, shared, favorited, and subscribed to these videos. Really appreciate all your continued support and look forward to continue this awesome project of ours. See you next time.